Welcome to the course Environmental Monitoring and Instrumentation. I am Dr. Pushpa Tuppad, Professor, Department of Environmental Engineering, Sri Jayachamrajendra College of Engineering, JSS Science and Technology University, Mysore. I completed my Bachelor of Engineering degree in Environmental Engineering from the same institution, did my Masters from NITK Surathkal and PhD from Kansas State University, Kansas, USA. I have been actively involved in watershed river water quality modeling projects to assess the impacts on water quantity and quality due to non-point source pollution, agronomic and structural best management practices, and climate variability. I have also been worked on water supply and distribution network, ETP design and audits, and green audits. This is about me. Coming to the course, there is a saying, without monitoring, environmental change goes unseen, and what we can't see, we can't correct. In other words, to protect the environment, we must first understand it, and understanding begins with measurement. Our environment, the air we breathe, the water we drink, and the land or soil we stand upon is constantly changing. Monitoring these changes is key to addressing pollution, managing natural resources, and protecting public health. Now, what is environmental monitoring? Environmental monitoring is the regular and methodical collection of data related to environmental components like air, water, soil, noise, etc. This is a 3-credit course suitable for second year and above undergraduate students, which comes under 5.0 and above National Credit Framework. The course Environmental Monitoring and Instrumentation aims to equip students with a comprehensive understanding of environmental monitoring principles, techniques, and applications. Through a multidisciplinary approach, students will explore key environmental parameters, again, air, water, soil, noise, and radiation, while gaining knowledge of monitoring tools, instrumentation, and data analysis. The course emphasizes regulatory framework, quality assurance, and integration of emerging technologies such as IoT, remote sensing, GIS, artificial intelligence, and so on. By the end of the course, students will be able to design and implement effective environmental monitoring programs, interpret complex data sets, and apply monitoring strategies to real-world scenarios to support sustainable environmental management and policy making. Prerequisites is you have to have a basic understanding of environmental science and or engineering concepts. You have to have some familiarity with scientific measurements and laboratory practices, including units, sampling, safety protocols. You have to have some introductory knowledge of physics, chemistry, especially related to air, water, soil properties. And you have to have some basic computer knowledge of spreadsheets, internet-based tools, and simple data analysis software. And overall, above all these, you have to have some interest in environmental management, public health, sustainability, and other related fields. Outcome of the course: the student at the end of the course will be able to explain the principles and regulatory frameworks of environmental monitoring across air, water, soil, noise, and radiation domain. Student will be able to select and apply appropriate environmental monitoring instruments and techniques for accurate data collection and quality assurance. Student will be able to analyze and interpret environmental data using statistical methods, GIS tools, and data visualization platforms, and integrate emerging technologies such as remote sensing, IoT, in the design and execution of monitoring systems. Thank you. Further, the course content will be briefed by the course co-coordinator, Dr. Savitha Ulavi.
Namaste. This is Dr. Savitha U. Ulavi, Assistant Professor in the Department of Environmental Engineering, Sri Jayachamrajendra College of Engineering, JSS Science and Technology University, Mysuru. I received my PhD from Indian Institute of Technology, Madras, in the area of air quality modeling and monitoring. My research inclination include source apportionment studies, data analysis, predictive modeling using machine learning concepts, and advanced wastewater treatment facility. The present course is planned for 13 weeks with 30 sessions as per the guidelines of SWAYAM. And essentially, week 1 we're going to cover the importance of environmental monitoring, types of sampling, scales of monitoring like spatial and temporal monitoring, and regulatory frameworks associated with air, water and soil pollution. Followed by this, week 2 will focus on basics of sensors, data acquisition system for wireless sensor network, including SOP for calibration, maintenance, quality control and quality assurance aspects of the instruments deployed in the field. So week 3 and 4 together is designed to cater the knowledge on air quality aspects, wherein you will going to learn about the major anthropogenic sources, hotspots at city level, need for emission inventory and source apportionment studies, as well calibration, maintenance and deployment of air quality instruments in the field. Week 5 and 6 is oriented to provide details about water quality aspects and involve assessing physico-chemical parameters using multi-parameter probes, groundwater and surface water monitoring methods, emerging techniques. Week 7 will describe about the soil quality parameters, instrumentation knowledge to remediate contaminated sites and to understand soil and sludge characterization. Week 8 will provide domain expertise relevant to noise and radiation measurement and mapping of these pollutants. Week 9 to 11 will emphasize on basics of GIS, mapping of pollutants, remote sensing techniques, other emerging technologies available, as well use of AI and IoT in environmental systems. So this module will be very helpful for you to provide insights on the historical data you have gathered or the data you have gathered through monitoring techniques and development of dashboard to convey the information. Week 12 is planned to orient a learner on application to real-world settings, designing a monitoring program. This module will involve review of case studies. Then the question is that who is the target participant for this? Whether you are aspiring to work in environmental science, engineering or public policy making, sustainability aspects, then this course best suits you and offers a strong foundation to help you monitor, understand, protect our environment with confidence and precision. Grading scheme as per the SWAYAM guidelines will be 30% weightage for course assignments and 70% weightage to term end exam. Our industry partner to the present course is MESA's Environmental Health and Safety Research and Development Center located in Bengaluru. This lab has been recognized by Ministry of Environment and Forest Climate Change, Central Pollution Control Board of India, and the present lab is NABL accredited lab. So finally, we welcome to the course once again, and we ensure you that you will be glad that you choose this course. Thank you.